Welcome and hello. This is a video exercise on HEC ResSim, and in this exercise, we're going to be dealing with state variables. Actually, this is probably more of a script editor script exercise because I'm going to put the script in the cleanup tab of a script variable and ask HEC ResSim to perform the sort of some post-processing script automation and calculations. So if you're not sure what that means, just stick around. Let's get into it. Here on the screen, I have my HEC ResSim brand new instance. I just opened up the program here. And to get started, make sure you're selected the watershed setup module here in the module selector in the top left. Then we're going to go File, New Watershed, and give our watershed a name. Then go ahead and select the location you want that watershed directory to be saved to. Open. Select your units and then your time zone, and then click OK. Okay. All right. So our watershed has been created. Next, I'm going to zoom in and select this stream alignment tool, hold down Control, and then click a few times. Continue clicking, continue holding down Control. And then before your last click, let go of the Control button and give your stream alignment a name. All right, next, I'm going to select the computation point tool and then hold down Control, single left click, and then CP1 will be my name for that. This is the upstream end here. So when we're sketching our stream alignments, our reservoirs, our reaches, whatever, make sure to start on the upstream end. Next, I'm going to click the reservoir tool here and then hold down Control, single left click on the stream alignment at the upstream end, and then let go of Control, and then another click downstream of that where you want the dam phase to be. And I'll just call that reservoir 1. Okay, and then one more computation point at the downstream end just to be complete and okay. Next, I'm going to click watershed and then, configuration editor. Configuration, new. I'll just call this config 1. And then 1 hour is fine. Okay, apply, okay. All right, so let me go ahead and save that watershed. We're good there. Now, we will change the module to reservoir network. And the first thing we need to do is create a new network based on that configuration we just saved. So come down here and select config 1 and then give your network a name. I'll just call it network 1 and then click new. All right, so our network popped into place here. And next I want to connect the network here. So I'm going to select this reach tool here on the left tools menu and then hold down Control on the upstream junction, let go of Control, and then another single left click on the next downstream junction. All right, here's the name. That's fine. I'll just click OK and then repeat that process for the reach that's downstream of the reservoir. All right, so I'm going to go network save. Next, I want to assign a inflow to my upstream junction, so it'll flow down into the reservoir and then through the dam based on our reservoir rules. So I will click the junction tool and then right click, edit junction properties. All right, so let's see, local flow tab, and then make sure you're on the first line here. And then I'm just going to give that local flow a name. It'll just be inflow to CP1, factor of 1, apply, and OK. Next, we're going to define the time series for this particular inflow. Right now, we just said that it has inflow. We need to actually create what those values are. So let's go ahead and go Tools, HEC DSS View, File New. First, we want to create a time series data set. So I'll call it time series data.dss. This is in the directory of my watershed. I can put it anywhere I want, but this is probably a good place for it. So I'll click create. Okay. And now we have this time series underscore data.dss directory here in DSS view. So to create a time series data set, I could just go up to manual time series in the data entry manual menu item. And then here is my data I need to complete. So I will just be generic and call it project, location, flow. 1 hour will be my time step. That's true. We'll just call it H1 there. Let's do this for the month of July 2024. So I'll go 1 July 2024. It's an hourly time step. So I'll select the first hour and then CFS. All right, so here are the values here. I can type them in or I can paste them in. So I just pasted the values in here. And this is a inflow time series, which I will save and then show you what it actually looks like. All right. So it's an hourly time flow for a 31-day month. And then here is the plot of that flow itself. So you can see it, there's a lot of undulations around 1800, I would say is the average, 1700. But then it does get up to about 2200 and down to as low as 1300 over the course of a 31-day month. So we will revisit this plot a little bit later and assign it to an alternative. But we have that ready to go, so we can close that up. Now we need to edit the reservoir. So I'm going to click Reservoir tool here and then Edit Reservoir Properties. Okay, so here's our reservoir. First thing I like to do is rename the dam to just dam. Okay, and then let's go ahead and select the reservoir pool. And now I'm going to paste those some values in for the reservoir pool. So base elevation is 1350 feet, and then the top of dam elevation is 1500 feet with storage values that, of course, increase. Next, I'm going to select the dam over here and then type in my top elevation, and I'll just make up a dam length there. On the dam, I'm going to go right click and then add controlled outlet. And then I'm going to paste in some numbers here. So this has an invert of 1400. And then as the water surface elevation increases, so does the maximum capacity through that controlled outlet. All right, so that's good for now. I'll click apply. And then over at the operations tab here, I'm going to go operations new. I need to create an operation set. I'll call it operation set 1. Okay. It gives me the 3 default zones here, flood control, conservation, and inactive. That's fine. I'll just go with that and set a top of zone elevation to be constant for the entire year. So this is kind of boring, but it's not the focus of the exercise. Actually, let's go with 1400, top of inactive zone. Apply. Okay, so that looks good. Later in the exercise, we will be returning to this dialog and adding rules, but for now, I just wanted to run a simulation without any rules and see what happens and sort of treat that as a base case. All right, so next we need to create an alternative, which is going to be a base case alternative with no rules as well as no scripts. So alternative, new, I'll call it base case, and then okay. It'll be a 1 hour time step. Okay, the operation set is going to be operation set 1. That's what we selected. The water surface elevation in the pool is 1480. That's our guide curve elevation. So we'll start there for the look back period. And then the release, we're going to start at 1800 because that is the beginning release for the first hour for that inflow time series. So save that. Okay, oh, time series, almost forgot. So go ahead and select the record here. This is our inflow to CP1. And then click this Select DSS Path button. Next, we need to navigate to that time series data.dss file that we created. It's right here, open, and then here is our record. So when we click on that and then click this set path name button, then that assignment gets made for alternative for the inflow CP1. All right, alternative save. Then I'm going to go ahead and close that and then network save. All right, we're ready to switch over to the simulation module. So we'll do that. Then we'll go simulation new. And then I'm just going to call this simulation 1. And then I need to fill out the start date time. So again, this is July 2024. And this will be, I'll start this on the 2nd hour of the month. And then the look back period will be the 1st hour. That. And then the last hour of the month will be the end of the simulation. All right. And then let me select the base case as our alternative. It's our only alternative. And then click OK. All right, so we are ready to roll here. I'm going to click compute base case alternative, and it ran. So let's go ahead and take a look at the results real quick. Right click, plot. Here are the results. Pretty much as expected, the water surface elevation on this top plot is 1480 the entire month. And then on the bottom plot, we see the flow rate. So in black here is the inflow. This should look familiar based on our data we created in DSS view, and the outflow is exactly the same. That's in green here, which keeps the water surface elevation in the reservoir constant. All right, so that's fun. What I want to do in this exercise is use a state variable, maybe not so much a state variable, but rather use the state variable, use the state variable cleanup script to automatically run some post-processing on this simulation. And what I'm going to do is use paired data set. I'm going to calculate the flow for each day of the week on average that we're seeing in this release here. So we'll have a Monday value, a Tuesday value, a Thursday value, and it's not going to be a time series with 744 records like we're seeing as the number of hours in a 31-day month. We're only going to have 7 records. So that's what a paired data set is about. It allows you to specify the X and the Y values. It doesn't have to have one single value for every time interval in the simulation. So this is a little bit different, and that's why we're doing it. So we can learn some new stuff. All right. So let's go ahead and head over to the code. Before I do that, I'm actually going to create a trial based on this base case here so that we can have the base case as unblemished, untouched, something we can always return to and make copies from if in case there's a problem. So what I'm going to say here for the name of the trial one is add script. Okay. And then I'm going to edit the trial, not the alternative. So I'm going to right click on the trial, edit run. And then I'm going to head over to state variables. Okay, I got my state variables editor open up here. And there's, first of all, we need to create the state variable name. So I'm going to go up to state variables, new, and give it a name. I'm going to control V. I'm going to paste it in. Day of week release average is what I'll call it. Sure. All right. So the parameter name, I'll just say the same thing. So it makes it easy to remember. And then parameter type, I'll just say count. And then, yes, it will be a Python script type state variable. And we are ready to write some code. So what we have here in the main tab here is where we're supposed to write the code. It even tells us that. And then the initialization tab is initializing. This runs before the actual compute. Main, this runs during each time step of the compute. And then cleanup here is at the end after the simulation has been completed, what additional code needs to be written. This is actually the tab I'm going to write all the code in for this exercise because I want to reference all the release data during the exercise and do some post simulation analysis. Okay, so it tells me to add my code here. I will do just that. I will start by importing some modules from Python and Java. So we have some libraries to use, and these will be used during the code. So this exercise is going to be a lot of me pasting in code and explaining it. So you're not going to waste time watching me type too much. The next line of code is to actually open the file handler. And then to get that, I need a file name. And I need to actually create the file first. This is the DSS file. So I'm going to go over to HEC DSS view. Okay, I have DSS view open here. So I'm going to create a new .dss file and navigate to my watershed directory, open. And yes, so now I'll just give it a name. I have my time series data right there. I could just call it results.dss. Sure. And then create. Okay. It's opened the file results.dss. And then up here in the top, I have a file name, which tells me exactly where that file is located. So I'm going to copy that, return back to my script here in the cleanup tab, and then paste that file path in. And then ResSim also wants me to change these backslashes to a slash. All right, got that. Next, what we want to do is come over here to the API tree, and we want to open the DSS file to write to, and that is going to be, I believe, just it takes the file name. Right, so the parameter here is the file name, the DSS file to open. Looks good. Okay, so I will call that my FH, and then here is the file name here. So I'm going to paste that in for the parameter. And one frustrating thing that I came across when developing this exercise is that this is not correct. I have the HEC DSS library, not just DSS, so I need to say HEC DSS for this to work. So yeah, good luck with that. Okay, next I want to create my release time series because I need that time series data to actually get the average flow for each day of the week. So I'll call this release time series. Come up to our model variables here, reservoir, reservoir one. This is going to be the flow out. So just double click, and then that is our time series. Next, I want to create an object to keep track of the total flow and the number of hours as we loop through our release time series. We can keep a running count of the number of hours incrementing 1 hour at a time, as well as the total release. And then once that's all summed up, we can compute the average by dividing the total sum of the flows by the number of hours. So we can get the average flow per hour. And that will be on a day of the week basis. So we're going to actually have 7 different records here in this object. Okay, so to save time, I'm just going to paste in my initial object here for data. It's got hours and it has what I'm calling released sum, and everything is zeroed out here to start with Monday being the first day of the week, day 1. Day 2 is Tuesday, and yeah, so that's how that works. So just keep that in mind. And this actually makes it a little bit easier because the simulation is for July 2024, and Monday, the first of the month, is Monday is the first of the month. So that kind of coincides with this numbering here. Okay, now we need to loop through all the steps of that release time series. So I'll just say loop. We need to get the number of steps in this time series so we can loop through them one at a time. So I'll just say num steps total release TS, and then I need to grab the number of steps from the time series API. So I think there's a num steps. Okay, so there isn't a num step showing here. I think it still exists. So I'm going to select this time series class here in the API tree. And then on my keyboard, I'm typing F1. And that brings up the documentation. So let me just bring this over here. I think it's in here. Okay, get num steps. Okay, there it is right there. Get num steps returns an integer, takes no parameters. All right, close that. Get num steps. So I just show that because we don't see it over here, but there are a lot of methods in this time series class you're not seeing here. Just keep that in mind. If you think a method exists, it might be worth checking the Java docs to see if it really exists, even if you don't see it on this list. All right, so let's go ahead and step through all the steps. We'll say for step in range total, and then +1 because I'm starting at 1 instead of 0. All right, so inside this for loop is where the magic happens. Okay, there was a quick typo. I needed to, here I'm going to paste in what I should have written. There's a comma right here instead of the word to. Okay, next time I'm just going to paste some code in. And what I'm doing here is I'm getting the release from the time series, and I'm getting the day of the week. So, and I also have this look back duration in hours because the simulation doesn't actually start until the second hour. So there's a look back duration of 1. Otherwise, I would be off. My release would be off by the number of hours in the look back period. So here's my release value. I'm getting that from my release TS time series. And then day of week integer is going to be a value from 1 through 7. So we can write that into our object on the correct day of the week. And then we're sending it the step. So I need to write a function that gets the day of the week based on the step or the hour of the month. Okay, so I've written that, and I'm going to just put it right here, just beneath the imports, and paste. So here is that function. Pretty straightforward here. So I'm passing it the step, and then I'm dividing by 24 to get the day of the month, because there's 24 hours in a day. And then make sure that's an integer. And then here is the day of the week. So I'm taking the modulus of 7. And then this line right here is make all the zeros Sunday to be 7. So that it's 1 through 7 instead of 0 through 6. So that's what this is here. In the comments, I made it just a little example for me to figure out what I'm doing. So if the step was 200, then the day of the month float would be 8.33. Rounded up, that would be 9, which means it would basically be 8 hours into the second Tuesday, which all we need to know for day of the week would be a 2 for Tuesday. Okay, now that we have that, we can now update that data object. So we are writing the hours. We're just incrementing that 1 hour at a time based on the day of the week. And then we're also summing up the releases. So we're keeping track of that for each day of the week. Okay, just below that, I'm pasting in a couple lists. I'm creating a list for the day of the week, and this is just going to be 1 through 7. And then the release average list. So I'm going to calculate the average value based on the data that we've collected in the previous step. So up here, it's just the total and then the number, and then we can divide the total by the number and get the average for each day of the week 1 through 7. So think of these two lists as sort of your X array and your Y array because it's paired data. There's going to be an X and a Y value, sometimes multiple Y values if there's multiple series. But in this case, we're just going to go with one series. Okay. Next up, I am creating the paired data container. I'm just going to call this object PDC. So the documentation for this is in the Java docs. I'll actually leave a link to it in the description so you can see what's going on here. But what I want to do is create a name, a path name. It's going to be day of week / flow as the parameter. It's going to be 1 hour, and then I'll just call it DOW flow for the part path. And then a few other things we need to specify is the coordinates. So that's the X list. And then the Y coordinates, it needs to be inside of a list. So that's why I've got it surrounded by brackets here. Number of curves, 1, and then the number of ordinates. All right, we're ready to write that paired data container to the file. This is FH is our DSS file. So the put command, our method is what we do there. And then we'll close the file and then write a message to say that it's been written successfully. All right, so those are all the steps that we want to add to our script here in the cleanup tab. Let's go ahead and save this and then run the compute once again, which will invoke this cleanup script once it's completely done. Let's go ahead and go state variables, save. I'm going to move this to the side for now. Okay, over here in DSS view, I have my results.dss file. I can go in view and then refresh, and we don't have any records here. So after we run the compute, I'll return to this screen, refresh it, and hopefully we'll see our table of 7 different average flows for each day of the week. Let's go ahead and compute this trial. Okay, that's good. So we have a new dialog box here that popped up that says average flow data was written successfully. Okay, we'll see if that's true or not. Back over to DSS view, and I'm going to go view and then refresh. So here is our record. I'm going to click the tabulate button, and sure enough, here are our data values. So we have the days of the week, 1 through 7, and then here are the average flows. We have 1742, 1774, 1834, 1872, and this looks correct because we knew that the average flow was about 1700 to 1800. So these numbers are in the right ballpark. And then 1 through 7 is Monday through Sunday. This will be our base case. I want to create a couple release rules that will force the flow on Tuesday and Friday to be higher than average. And we'll see what happens with that. All right, so let me go ahead and minimize that. And then let's go ahead and add a new trial for this. New trial. I'm going to say add rules. So I'm going to have some minimum release rules that are above that 1700, 1800 neighborhood of flows just to get some different values in our results table and confirm that it's actually doing what it should. So I'll click OK. Now I'm going to go ahead and click state variables. So I'm modifying the state variables of this trial 2. The only thing I'm actually going to modify is the part F in the file name. Go cleanup. And then part F is instead of DWR flow, I'll call that rules and then save. That'll create a distinct file path. I could call it trial 1, trial 2. That's fine. Okay, so let's move that out of the way. Now I actually have to create the rules. So I'm going to go over to reservoirs, operations tab, and then let's add new rule. I'm going to call this Tuesday min 2500 CFS. It'll be from the controlled outlet and a release function rule. So click OK. Minimum, this will be for the date. I will say 2500. CFS is the minimum. And then down in the day of week multiplier here, I'm going to just put 0, 0. Tuesday, I'll leave it at 1, and then 0 everywhere else. Okay, and apply. All right, so let's add that to all zones. Let's do the same thing or a similar thing for Friday. Add new rule. I'm going to say Friday here. And let's say it's a minimum of 3000 CFS from the controlled outlet, release function, date, and then our number is 3000. That will be a minimum flow. Again, day of week multiplier, we want to set it to 0 for all the days except Friday. Okay, so there's that. And then apply. I'm going to go ahead and add that to all zones. And let's just create a minimum flow of 500 CFS for all days, just so that it doesn't drop down to 0, because I don't want that. All right, so I will paste in, I'll just say all days, minimum 500. Let's go 400. Controlled outlet, release function. This will be, again, simply defined by the date. It'll just be a constant 400 minimum, and then also copy to all zones and apply. All right, looks good. So let's go ahead and compute. Okay, again, the data has been written successfully and close. Let's go ahead and take a look at the releases first. So here's the plot. And yeah, cool. So it shows here in the bottom plot, we have our inflow, which is the same as it was before. And then in green here, we have our releases. So Tuesday, July 2nd is a Tuesday, and then we have a Friday. So a 2500 release on Tuesday, 3000 CFS release every hour of the day on Friday. And then it repeats Tuesday, Friday, Tuesday, Friday. What's happening down here is the reservoir is trying to reestablish its guide curve elevation of 1480. So it's releasing as little water as it can for the first few hours here of Wednesday morning each week. And then again on even more so on what would that be, Saturday morning, or really most of Saturday, because the 3000 CFS is a larger downstream minimum flow requirement than the 2500 on Tuesday. So that's cool. So what we can expect from those average flow rates when we look it up is the highest number is going to be Friday, and it's going to be 3000 CFS if everything worked. And then on Tuesday, it's going to be 2500 CFS. And then like on a Friday and a Monday, those will probably be the same as before, pretty average, 1700, 1800 range. But then we can also expect that our Wednesday date will be lower than average because of this drop. And then the lowest is probably going to be Saturday to recover from that large release on Friday. Okay, so enough talking. Let's go ahead and check out the numbers. I'm going to go over here to DSS view and then click view, refresh catalog. Here's our new record here with the rules imposed. And then if I click tabulate, then I see, yeah, so this is this is good. So here's Friday of 3000. Here's Tuesday of 2500. Again, Monday's pretty normal. Thursday is pretty normal, but then with the Saturday, it's very low, and that's because it's recovering and it's releasing its minimum of 400 CFS for most of the day. And then another lower than average day is going to be here on Wednesday, where it's recovering from additional releases the day before on Tuesday. This is the paired data right here. So I've got day of the week 1 through 7, and then the average flow rate in CFS is here in the Y column, the second column, which is the dependent variable. So this was an example of state variables, are one way to use state variables in ResSim, really as a post-processing. So you can use the Jython code and the script to do all sorts of post-processing calculations in ResSim.